Okay, we're going to pick up where we left off in class. With number 46 here, we're going to do another example of using substitution. So typically, a good choice here, as it states, a reasonable choice would be to make u equal to the big part that's here in the parentheses. So let's see what happens after we substitute that and how we can solve that. So we would have u plus u to the 1/2 power minus 6 equals 0. Okay, now I don't know about you, but I'm not sure how to factor that. I have a power of 1 here and a 1/2 power, and yeah, I'm not exactly sure what to do with that. It's still somewhat difficult to solve. So let's try this suggestion here. What if we make v equal this to the power of 1/2? Well, to the power of 1 would be equivalent to this piece squared. So let's try this. We're using a v, just another variable besides u, so we don't confuse the two. But this piece would then be v squared, and this piece would be v to the first power, and then minus 6 equals 0. I know it's a kind of strange thing to choose for substitution, but it makes it a lot easier to factor. So at this point, then we can go ahead and factor this. V and phi, let's see, 2 times 3, and we want this one to be positive and this one to be negative, so u is positive 2 or negative 3. Oops, I switched. It's supposed to be v. There we go. So now we can plug that back in here. If 2 is equal to m squared plus 3m minus 1 to the power of 1/2, we can square both sides, and that takes care of that. So we end up with 4m squared plus 3m minus 1, m squared plus 3m, subtracting 4 from both sides, so get negative 4. Then factor again. M is 1 or negative 4. And then we try this one when we set it equal to 3, or negative 3, that is. M squared plus 3m minus 1 all to the 1/2 power. Raise both sides to the power of 2. We square this, we get 9. 3m minus 1, subtract 9 from both sides to get m squared plus 3m minus 10. And factor yet again. M minus 2 times m plus 5. So m is 2 or negative 5. And there we have it. Okay, next, completing the square. We're going to take a look at a situation Okay, so the idea of completing the square, if we have um, an expression like x squared plus 8x, we can represent this with algebra tiles. It would be having one x squared piece and then 8 of these. 3, 4, 5, 6, 7, 8. Did I get 8? I guess not quite. Well, I'm going to start arranging them because it says completing the square. The task is to make it a square. So to make something a square, I need to put, come on, turn, won't ya? There we go. I need to put the same number on each side. So I've got 4 over here, 2 over here. I need 2 more. Okay, rearranged a little bit here so it would work easier, but I've got 1x squared and now I'm going to put in 8 x's. And to make it a square, 1, 2, 3, 4, I'm going to need 4 that go that direction. And then I'm going to need 1, 2, 3, 4 that go this direction. So let's move these around so that it actually makes a square. And the only way I can put these is this direction because they match up the side length to the side length. So what would I need to put here to, in truth, like exactly what it says, complete the square? Well, I could start putting in some of my little positive units here. 1, 2, 3, 4. How many is it going to take to fill it in? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I could have figured that out before because here along the side, got 1, 2, 3, 4 units on this side. And 4 units along this side. So when I factored now, I've got an x plus 4 by an x plus 4. It's a perfect square, the exact same length on either side. So I would have to add 16 units to complete my square. And then the dimensions of my square are x plus 4 by x plus 4. X plus 4 quantity squared is equivalent to what we have up here. So there's our reminder of how to complete the square with algebra tiles. So let's look to the next problem and apply that. Okay, so for part A, here it says to use completing the square to change this into this form of an equation. So I'm starting with y equals an x squared and 8 x's like we did before. Well, you have to take your x's and divide them in two pieces, the horizontal ones and the vertical ones. So we're going to have 4 on one side and 4 on the other. So 8 divided by 2, that makes 4, and then we square that, and that's determines what we're going to add to be able to make it true. So we end up with adding, well, we're going to have to add 16 units to each side of the equation in order to keep it balanced. And 16 is what completes the square, half of the 8. So 8 divided by 2 and then square it, and you get 16. So when we factor this, that's where we get this parentheses format. So we have y plus 16 equals x plus 4, just like we had with the algebra tiles, quantity squared. And then to finish the format, subtract 16 from each side, and we have y is equal to x plus 4 squared minus 16. And now it's in that format where we have an h and a k, and we can easily graph this. We know exactly where our vertex is. The vertex is at -4, -16 for that parabola, and it's opening up because it's positive. Okay, so let's try this one more time. Let's try this one right here. Okay, we've got a -1 already. So let's just move that to the other side, get it out of the way. So we have y plus 1 equals x squared plus 6x. Okay, so when we're completing our square, just to draw a little picture to go along with that, here's our x squared, and then if we've got 6 x's, we have to do three of them horizontal and 3 vertical. And then how many goes here? Well, half of that squared, 9. So we're going to have to add 9 to both sides. So that gets us y plus 10. And then what's the factored form of this? X plus 3 by x plus 3 is the square. So it's x plus 3 squared. And then we subtract the 10 from each side. So y is equal to x plus 3 squared minus 10. And now we know our vertex. Move into the next one. Okay, so what if we want to graph this? And I have no graphing calculator and I don't want to make a table. I just really want to know where the vertex is. So let's put it in graphing form so we can complete the square. So let's subtract 3 from each side. Y minus 3 x squared plus 6x. Okay, remember the picture. What do we need to complete the square? Well, 3 x's on each side, because we take this and divide by 2. After dividing by 2, we square that, we get 9. 9 is what we add to complete the square. We have to add it to both sides to be fair. Y plus 6 equals, and this factored is x plus 3 by x plus 3. So x plus 3 squared. Y equals x plus 3 squared minus 6. All right. What about this one? Sometimes we can actually rearrange using the completing the square to make this the graphing form for a circle. So we do completing the square twice by grouping it together. So we do completing the square for the x's, complete the square for the y's, and then we end up with a circle. So x squared plus 6x, and to complete this square, we take that, divide by 2 and square it, we would get 9. So we're going to need to add 9 to the 51 over here, because we have to add to both sides. And then we'll do the same thing here. So plus y squared, and we need to split the -4 y in half. -4, that would be 2, and 2 squared makes 4, so we add 4 to each side. And so let's factor all of this part. That would leave us with an x plus 3 quantity squared. And this piece factored is a y minus 2 squared. And then we add all this together and we get 64. So, if you recall how to graph a circle, now this is h and k. This is the center of the circle. The center of the circle will be at -3, 2. And the radius of the circle is always this piece square rooted. So square root of 64 would be 8. So we can actually sketch that circle. All right, one last example. Well, what if the coefficient, the number before x squared, the leading coefficient, is not 1? How can we possibly deal with this? Well, just like usual, let's get this 1 out of the way. Subtract 1 from both sides. So we've got y is equal, y minus 1 equals 3x squared minus 18x. The next step would be to factor out the 3. So we've got y minus 1 equals 3 times x squared minus 6x. Okay, now what would we need to add to this to complete the square? Well, if I take the 6 divided by the -6 divided by 2, get 3. 3 squared makes 9, so we add 9. Okay, so what did I really just add to the side? I added 3 groups of 9. So I need to add 3 groups of 9 to this side as well, which would be the same as adding 27. So we add that together and we end up with y plus 26 equals 3. Factor this, x minus 3 squared, and then we can subtract the 26 from each side. And then we have our leading coefficient of 3, our stretch factor, and we still know where the vertex is. It's in the same spot. All right, that's it for this video.